Hi, Simon here, GM8NYV, continuing on with my CR100 restoration. I've done a little bit more this week, and I have a little test I want to do with the main tuning capacitor. Now, I had a comment, and quite a valid one, I never really thought about it, from Angelo, and he mentioned that when he did his CR100 he used screened lead to the grid of the valve, the oscillator valve, from the main tuning capacitor, and it says it puts the alignment right out. So I had a thought about it. When I had a look at pictures of mine, I never really looked at it before. I looked at the pictures of my one before I dismantled it, and sure enough, the lead from the oscillator section of the variable capacitor up to the valve is just a plain wire. It's not screened where others are screened. I thought I'd do a little experiment, so I'll show you the radio first, and then the experiment I did was to add a piece of coax and measure the capacity with a piece of coax on it. So a little bit of coax probably adds in parallel, like two parallel capacitors together, so we'll see how that little experiment goes. Okay, I've now wired up most of the RS side. This circuit board was the last one I put in, this tag board I should say. Each of the valves I've wired up to its appropriate resistor and its appropriate capacitor. Now there are a few you can see here that have nothing attached to them yet. These are connected directly to the coil pack, and also a few connections on the coil pack go to the valves. So that's all ready for the coil pack to go in. It's going to be quite a tight fit getting in there with soldering iron, but I think we'll manage. Also, it's getting a bit crowded here. I've got most of the wire. I'll loop them around the back down to the, instead of running them along the bottom there, around the back, and a bit congested there, but it's not too bad. And because of the smaller wires than the originals, the smaller diameter insulation, it's much easier. There's quite a few going in here, and I've also put the HF pot, gain pot on it, so I'll just turn it over and have a look. Well, that's the top of the chassis with the IF cans on. There's still the BFO can to go on yet, and obviously the other parts that go on the top. I'm not sure you can see on this one, there's the HF pot. If I just turn this round, get a better view of it here. Put the bracket on. I haven't really tightened that up much. I might have to move that up and down to get the position when it goes through the front panel. There's enough leads left on here. Now the top lead here is the counterclockwise position, which is grounded here, and then the other two go to the HF, the boards underneath. So I'll zoom in there a bit better. Drawing the two up here was easier than drawing them both to the capacitor that's underneath, which was C70. So that's how far I've got this week, and they're slowly taking shape there. So I'll do this little experiment with the variable capacitor and see how it performs with that added piece of coax on it. Okay, there's the variable capacitor there. This is the capacitance meter. Try and trim out the zero there. Now on this side here, I've got the one side of the meter just clamped to the case here with this tweezers. There's the other one there. So I'll put it. This is a capacitor fully closed. I read it there. It's about 443 pf roughly. According to the book, it's supposed to be 437, so not too worried with the length of the leads and this clamp on here. So that's it fully meshed. Now if I open it, longer than I thought. I won't fully open it, but I'll just... And then measure it fully open. Measure about 11 there. Yeah, so open connection. As you close it, goes up. Right, I'll close that again. And then we'll solder on a piece of coax, a small piece, about the length of the valve. Alright, 443 again, okay. So this is my piece of coax, and I'm going to solder it across the capacitor there. Okay, I've connected up the coax on the terminal of the oscillator capacitor and the other end to the ground of the chassis. The meters are the same. Now the coax is open at this end. It's only a short length. It's about the length of the valve would be, and it's open at that end. Obviously, don't want to short it out. And we'll see what we get here. I remember before we had about 440, 439, 40. So now it's 457. It's reading there. So it's definitely gone up by about what, a good 15, 16, 17 picofarads. That's with it closed. So let's quickly open it and see. I didn't mark the halfway point, but I'll guess it here as we go. A bit slow on the slow motion drive. Try and push it along a little. Noisy. That's about halfway point. It was hard to. I had 138, but I didn't mark the halfway point. But we'll go to the fully open part. I remember it was about 18 pf with it fully open. So we got about 33, 25 with a hand off it. So it's gone up by 5 or 6 pf having it in this fully open bit. Right, I'll close it again, and what I'll do is just put a single piece of wire on here now and see how that goes. Right, I've closed the capacitor again, and at the moment I've disconnected the ground side of the coax there. So it's just this piece of coax still open that side. This is just a rough check, obviously we've got a lot of straight capacitance about. But there we are, 446, so it's still a bit higher than when there was no wire on it. That's just the inner core connected. What I'll do now, I'll quickly just use the outer core of this. I haven't got a piece of wire to try it on, but I'll use just the outer core if I can solder that on quickly, just see if it makes a difference. Tack it on there. Right, let's measure this again. So that's just the braid on its own, and measuring 445, so it looks like a single piece of wire is probably much better. I've got this stuff here, try that out of interest. Now I can quickly tag that on. Where are we right? I've just put this piece of wire on it, quite long, it's longer than what's necessary, and we'll measure again with one piece of wire attached. Still hovering around the 440 mark, still a bit high than without the wire on it. So basically that just goes to prove what Angelo mentioned on his restoration, that when he used coax it put his alignment out, which is probably why the capacity, there's only small pieces, is 714. It's quite low loss. Now I've used different coaxes, I'm sure I'll have different capacities, but that little bit there must be about 10 pf then. Remember back in the 70s and 80s when I used to get Practical Wireless monthly, I used to have some little magazines building regen radios. They used gimmick, as in inverted commas, capacitors. There was always a piece of coax with it twisted pair together, to make as I said, a gimmick capacitor. Okay, well that's something to note for when I rewire it. Well, that's the chassis here. All the eyes are on. These I think because I've had it upside down, they've got a bit twisted, but I think they'll be okay. I need to check them though that I haven't come adrift inside. HF pots on. Inside I've done the wiring for the two boards, as I explained earlier. Just the coil pack wiring on it to go on. Next I'll probably concentrate on the transformer at the back here. These wires here are for the 100 Hz filter. That's still to go on there. Then there's the audio transformer there, and of course the main tuning capacitor, which will probably not go on to the end. So this is HF pot, HF gain. It's not, the bracket's on, but that's still loose, so just to move it up and down because I'm not sure the alignment for the hole in the front panel. The front panel I'm going to have to look at. I've still got to clean it all up, probably respray it and put new lettering on it. That's the passband switch, my new on-off switch here, the mode switch, and this in the corner, you see it there, is the low frequency gain for volume control. Right, so not a lot left to do, and then this tuning capacitor obviously sits here. If I can find out where to go, that's going to sit about there. Obviously, that knob doesn't. So I'll just put that on so I can move it. Anyway, hopefully you found that useful, and I'll see you next time. Bye bye.